here on the PSI booth with Roger, who's going to show us not a loudspeaker but some active room correction, I believe, and that's something I haven't seen in this smaller format before. Now we know what active room correction is. I mean, essentially you're looking at a wavefront and trying to counter it by generating a counter wavefront, if you take it really simplistically. But can you tell us the fine detail on that?
Yes. I'll just tell you where we come from. We've been making monitors for 40 years and we've been trying to make them as accurate as possible. But what we find is when we put them in the room often contributes to, is part of the problem. So we've been thinking about making active absorption, as we make active speakers for 25 years, making active absorption also for about 20 years. We had a first diploma with the University in Geneva 20 years ago, and 3 years ago we got a grant from the Swiss government to work with academic partners, with another industrial partner also, to develop to work on this active absorption. So we worked with the University in Geneva and the Polytechnical School in Lausanne for 4 years with a team of 8 people on it. And we've ended up with this commercial product and 2 patents, one in the analog domain, which is this one, which is ours, and one in the digital domain. So you should think of it as absorption. It's not anti-noise, it's not phase cancellation or whatever, it's just absorption. How it works is when you have a wall, you have a pressure build-up. There's always a correlation between pressure, acoustic pressure, and acoustic velocity. And energy conservation dictates that if one goes up, the other one goes down. So when you come against the wall, the velocity is de facto 0 because the wall is stationary, if it's rigid. So the pressure builds up, and that's what creates the background, the echo, and it comes back. What we try and do is punch holes in it so that the air can go through, which avoids the pressure to build up. So basically what we're doing is we're trying to transform pressure into velocity. You should imagine a bucket full of water where there's pressure at the bottom. If you punch a hole in, the water will come out with velocity but no more pressure. Now, what happens behind this mesh, it's actually a micro-perforated grill, and behind this is what we call the silent chamber. And behind that, you have to keep 0 pressure, but you have air going in and out. So you have to compensate for this volume of air going in and out with a loudspeaker, that's an active loudspeaker that goes in and out to compensate exactly the volume to keep 0 pressure. So with all of this, you're dictating a impedance on this grill that's inside here of about 100. That's 4 times less than in the air, in the surrounding air. So this means it's much more effective than a perfect absorbent material. It works between 15 and 150 hertz. That's what it's designed to do. We could go higher with another design, but that's what it's designed to do. So it's meant to treat the first room modes in any room. So you should think of it as a device that you put in the corner or somewhere else if you want to treat only one single mode. The corner is the best place because you have the 3 modes, but you can put it in front of any other. If there's one single mode you want to treat, you can put it in the middle of a wall also. And you turn it on, there's absolutely no calibration, it just goes on and off. We'll show you some details afterwards. And you should think of it as being in the corner, and it's got 100 pascals per meters per second as impedance on it. It means that the impedance will grow up to 400 in the surrounding air, approximately 1.50 meters away from it, or 1.5 meters away from it. And that's basically this sphere of about 1.5 meters around it is the equivalent surface at 100% absorption in those frequencies.
Right. So the advantage is that it's much more effective than a hole in the wall of the same size.
It's as effective as a hole in the wall, about 15 to 20 times its size, depending on the frequency and which corner you put it in, yes.
Well, it sounds impressive, and it sounds like exactly the thing some small studios could use. So what's the kind of pricing and availability on something like this?
So we've just started production. Availability, they're available in most of our dealers around the world, and the price is approximately $2,000 a piece.
Okay.
Plus tax.
And to treat a typical room, say something that's 15 feet by 10 feet, how many would you need?
Well, it depends on what results you want to achieve. But typically, rule of thumb, 2 of these would work up to about 20 square meters, 200 square feet approximately, and 4 of them will work up to about 60 square meters, 600 square feet.
It's certainly something we should try. Well, thanks for that.
Thank you.